Get started? Okay. I'm going to go ahead and get started just a few minutes early. I have a lot of content, and I would really like to get through it all. My name is Sam George. I'm a group program manager on the Windows Phone team. I'm part of a team that for the last year built a brand new C and C++ gaming platform on Windows Phone. So I'm really proud of what we've done, and I'm really excited to tell you guys about it today so that you will have the context for how to take advantage of it and how to make money on Windows Phone with games. Games are a hugely popular application segment on phone, obviously. Let's move on. Okay, so as we were designing this new gaming platform, these were the goals that we had in mind. And the goals were based on needs that we heard loud and clear from developers. The first was obviously to support our existing gaming platform of XNA. We've done that. And I'm not sure if you've heard in other talks yet or seen, but we changed the entire operating system. So this was actually much harder than it might sound. Like thread scheduling changed. So anyway, the next was to reduce the cost to target Windows Phone with games. One of the things that we heard again and again from developers, a lot of games are written in C++ now. C++ is a new portability, and as people are targeting more mobile platforms. And one of the things we heard over and over was that XNA and C# or VB was too big of a barrier to entry to Windows Phone. And as a result, we were having trouble getting games. That was one of the biggest things we wanted to go and address in Windows Phone 8. The next is to give you enable cutting-edge performance. No surprise that games need that. And the last was to make it easy to make money. So how did we do on all of these? Well, we think we did really well. We're really happy with what we've got now. Number one, Windows Phone 100% supports C++. Not only in our gaming platform, as you'll see, but also in our XAML application model. You can reuse your own C++ code, as you saw in the keynote today. You can use open source C++ libraries, such as Cocos2D or SharpDX, which are both supported on Windows Phone 8 now. We've also been busy this year going around and working with competitive middle game solution providers. Over half of games use some sort of middleware. And as you'll see shortly, we've got some great titles lined up, or some great game engines lined up. You saw Havok on June 20th. Havok's here with me today as well. You saw Unity in the keynote today, Fmod, Scaleform, WWise, Marmalade, and there's more that have announced support. And last, as we were going about building this new native gaming platform, we wanted to do it in such a way that it was aligned with what you will find on Windows 8. Because since we were building a new platform, we thought it would be rude if we built something that you had to write in a different way to Windows Phone as opposed to Windows 8. So the thing you'll see today is that we have the exact same application model. We have a very large API set that's shared with Windows 8. Cutting edge performance. So that new API set that's shared with Windows is available to C++. It has everything you need to build games. We give you low-level access Direct3D 11.1. This is the exact same version that you'll find on Windows 8. It's also the APIs that we call when we're building the phone experiences ourselves. For audio, we have Xaudio 2, Wasapi, IMF Media Engine. I'll demystify those for you, for those of you that aren't familiar with them. For video and cutscene transitions, we have IMF Media Engine. We have all the networking you'll need. And we also have all the other critical subsystems covered. And last, making it easy to make money. We've added in-app purchasing, which we're really happy about, both for consumables and durables, so for gold coins or poker chips or additional game levels. We've also made it easy. Let's say, for example, you have an XNA game that's built against Windows Phone 7.5, and you want it to use in-app purchasing, but you don't want to recompile it and target Windows Phone 8. We've also made it possible to build LightUp so that you can take advantage of in-app purchase from your 7X apps. We have a new global marketplace. We're supported in 191 countries, 50 languages. We continue our existing mobile operator billing, which is super convenient. It means your users, if they want to buy your app or buy things inside of your app, can bill it directly to their mobile operator account, and they don't have to set up a credit card. We also support international credit cards, PayPal, and a bunch of new local options. So, a picture is worth 1,000 words, and a game engine's worth even more. So with that, I would like to invite Russ O'Dwyer, Head of Developer Support from Havok. You can clap for him if you want.
I don't know. Oh, this is on. Great. Sam, thanks so much. So it's great to come up here today. We spoke in June about our support for the Windows Phone environment, but I'm here today to reaffirm our commitment to the Windows Phone and also to the Windows 8 ecosystem. We're going to launch next month Havok 2012 with full support for all of the Havok product line against Windows Phone and also for the Windows 8 ecosystem covering desktop, Surface RT, and Surface Professional. Havok is pretty well known in the industry at this point for the technology that we've brought to bear through the years, but also for the relationships that we hold with our customers. And over the last 14 years, we've been involved in helping those customers to ship hundreds of AAA titles. We're really, really excited about taking some of the technology used in those games, putting it in the hands of Windows Phone developers, and are thrilled and hopeful as to what's going to come down the line and what's going to be released on this platform in the next few years. Havok's all about enabling 3 key capabilities for our customers. The first is immersive and truly physical 3D worlds. The next is highly realistic and interactive characters, and the third is cinematic visuals. The demo that we're going to show today brings together those technologies and those capabilities live running on Windows Phone. And I think we're going to give a quick preview of one of those demos now. So I'm going to talk more about some of the features that are going on inside this demo later on, but we have 100,000 triangles being rendered in real time. There's dynamic particle effects, shaders. We're using a number of different Havok products and all running at a very constant frame rate on the phone. So working with the phone SDK has been a dream for us. When we first spoke in June, we'd only ported a couple of our products over. And we did that quite quickly. But over the last few months, we've been bringing all of our other technology across as well. And being able to work inside Visual Studio 2012 is obviously great. It's very familiar. It's a really comfortable environment for developers. But it's more than that with the phone SDK, because we get access to building apps straight on top of DirectX 11. So we had a PC render built already for DirectX 11, and it was really straightforward to bring that right across to the Windows Phone. But even beyond that, quite often when you're working on phones, you require a lot of devices. The emulator support that ships with the SDK is really, really powerful. And it meant that we didn't need to have that number of devices. We were able to work really effectively as a team. Everyone was able to see very quickly all of the work that they were doing running in an emulator. And that mapped very closely, exactly to what was running on the phone. Beyond that, Havok is known for performance. So we do an awful lot of work optimizing working low-level hardware features. So the native code access that was granted on the latest phone SDK has been really, really great for us in terms of getting the kind of performance that we expect from our technology. This demo brings together a number of our products underneath the umbrella of Havok Vision. Now, Havok Vision is a cross-platform game engine. It's built from the ground up with professional game developers in mind. It features industry-leading, technically rich feature set that's built on top of a very flexible C++ architecture. So out of the box, it supports Lua scripting. But beyond that, when you're working with an engine, you often want to modify or change or extend elements of the engine that you're working with. And a lot of the game engines that are out there, this is impossible. Vision is built on top of a flexible C++ component-based architecture. So you can actually go in, rewrite whole sections of the engine or extend sections of the engine using C++. We have a really good track record. At this point, 200 games have shipped. This isn't including Havoc's other products, but just using Havoc Vision, we have over 200 shipped titles on the PC and other platforms. So I'm going to take a look now at our tool chain. So this is vForge. It's the editor that forms part of the Havoc Vision technology. And it's a WYSIWYG editor. You work inside your modelers, Max and Maya, your artists export, and you load them straight inside the tool. We can work inside the tool and edit various different bits and pieces in the scene. It has a number of mobile-focused optimizations to try and help with mobile workflow. So we can toggle inside the tool the actual mobile render. So we get an emulation of the mobile render within the tool, so we know what it's going to look like on mobile. We've put in specific features for shaders and our particle editors that are focused for mobile. And we've done a lot of work to reduce the number of draw calls for our mobile render, which is obviously critical when you're trying to get your games running at frame rate. Picture is worth, as you said, 1,000 words. So I think from here, we're going to actually take a look at this scene running on the phone. OK, so in the scene, we have 100,000 triangles, as I mentioned before. You're going to see projective texturing. There's some interesting shader effects going on, so I'm not sure if you can see those, but whenever he walks behind something, an X-ray shader is shown. We have pretty advanced particle effects. It's running Havoc Physics for collision detection. Havoc AI is there for navigating those characters around the scene. Now, granted, obviously, the first scene you saw was a little more complex, and so the AI pathing was probably a little more impressive than that. But there is Havoc AI running in the scene, and Havoc animation and behavior are being used to drive the animations for the characters and the state machines for those animations. So we know that giving technology to people is really powerful. But even beyond being able to put technology in their hands, if they can't have the right tool chain, then they're going to be at a loss, because the cost of development is not just nowadays about developing the technology. It's about building the tools and reducing the iteration time when you're developing games. Budgets for games have really, really soared. So we've put an awful lot of time into adding features to our tool chain to cut down the cost of mobile development. We have a file server technology that allows us to build inside the tool here. We only deploy the application across to the phone, and then the assets are streamed across to the phone. What that means then is that as we iterate on the assets throughout the day, we don't have to redeploy to the phone. We don't have to resync across all of the assets. We just sync across the changes that have been made. And that makes our iteration time much, much faster and the workflow much, much better for teams working with the tool. So if I go in and I select that guy there and I delete him and I say, OK, let's create an entity inside the world. And I'm going to give it a model. See. Scale that up a little bit. Move it. I spoke about extending functionality using components. That's exactly how, when we took our other technologies, such as physics and AI and so on, we added them in using this component system. So you can just code up your own components, your own extensions in C++. They appear here. I create my object. I can add in one of those components. It becomes a rigid body. I see all of my properties here. And when I play that inside the scene, I have rigid body physics. I have these guys running around. I stop, and I come over here, and I can export straight to the phone. So that's what happens when your resolution changes at the last minute. Give me 2 seconds. Apologies for changing that. So I export the scene. And now I come across to my phone. Oh, I hope I didn't do anything there. I may have pushed the wrong button. Apologies if I messed anything up there. Sorry. No, yeah, I want the wolf. I want the wolf vision back, so that may be the wrong one. Yeah.
That's it
There we go. Okay.
Yep.
Start the app again. Apologies, guys. Physics. The guy's chasing around. Now, beyond just working inside this tool chain, we've helped, as I said earlier on, a large number of teams to ship games. And you've got turnaround time, but then you've also got debugging. So when you're working inside a game, you want to be able to debug what's going on at runtime. And we have a tool called the Visual Debugger, which allows us to connect directly to a device, debug what's going on the device, and then also record that. So here I have a recording of a movie that we made on the phone earlier on. And you can play back and forth, see the physics that's running there. Here's a representation of the AI, of the characters. So all of these tools are available, working right now on Windows Phone. And we've been really, really pleased with how our technology has shown on the platform. We're really, really excited with what people are going to do with Windows Phone. Our technology, if you want to get a look at it, you can go to havok.com/build. There's a form there if you want to get access to the tech, and we can send it through to you. Or if you'd like to go downstairs today, we have this tech, these demos running on a machine downstairs, syncing to the phone, showing the live updating. And we'll be able to connect the VDB directly to the device, and you can see it connecting and debugging while the game is running. I think that's great.
Thank you.
Sam, thanks so much.
So it's super exciting for us to see some of the cutting-edge engines like Havok that are being written on top of our platform now, made possible by the fact that we're giving all this low-level access. So let's talk about the app model and APIs. So what we've done is we've started with our existing XAML application model. We've added a new large converged Windows API set that's available on both Windows 8 and Windows Phone 8. And that's everything from a common .NET frameworks to a common language runtime to a whole bunch of new subsystems that are available. And most of these subsystems are available to C#, VB, as well as C++ through Windows Runtime technology. We've added a brand new app model, Direct3D App. And for those of you that are familiar with Windows 8, if you go into Visual Studio and file new Windows Store app, you'll see a D3D app there. You'll also see one for Windows Phone now. On the XAML side, we've also added C++ code reuse, so you can reuse your own C++ from within your application, your XAML application. It's no longer sandboxed, which is awesome. And then the last thing that we've done is we made it possible to have islands of Direct3D inside your application and to render to them from C++ and have those automatically composited. I'll explain in detail how that works. This guy's just taking a picture all over. OK, so the first thing that I want to talk about is Direct3D App. So I'm going to go ahead and switch over to Visual Studio. And we will create a new project. OK, so here under the Windows Phone node, you see now there's Visual C++. This is our Direct3D App, native only. Go ahead and create a new one of these guys. So what this gives you is a class that inherits from iFramework View, which basically gives you the hook into the system so that you get notified when your application's starting and resuming and things like that, as well as when input's happening. It also gives you a simple cube renderer. And if I hit F5 on this guy, start this in our new Hyper-V fancy emulator. Building. Actually, I started a different emulator. While I'm on that topic, we support, I think it's 4 different emulators now. So here's the one I just started it in. The The one I just started in was a lower level, lower memory one, a 512 meg one, so that you can try your apps out in that. 512 megs is our minimum chassis spec. A lot of the new phones that you see coming out are 1 gig though. Okay, so what this app or what this template gives you is basically all you need to get started, to get hooked in, to get input, and to begin rendering. So I'm going to be building on this in a little bit, but let's move on. Switch back over. Okay, so some of the details on Direct3D app. It is C++ only. You can't use managed code if you wanted to inside of it. That's not a principled statement or anything. At some point, we will probably allow you to bootstrap the CLR and run managed code in it as well if you'd like. For now, we don't. It gives you full access to this new Windows Phone 8 API surface, which is a combination of both Windows Runtime APIs, COM, as well as Win32 style APIs. You can reuse your own C++ code either statically or dynamically, and this supports all the activation and lifecycle events. Okay, let's talk real quick about our XAML application model. As I mentioned, we'd added C++ code reuse. And again, this has full access to this new native API surface that we've added. It also adds Direct3D composition. So let's take a look at what that looks like. So we've introduced 2 new elements. The first is called Drawing Surface. So Drawing Surface is really intended for if you want islands of Direct3D inside your XAML application. You can put it anywhere in the XAML tree. It gets composited automatically with the other XAML elements. It uses a D3D swap chain, so there is a buffer copy involved, but you can put it anywhere. So for example, if you wanted to put a bunch of D3D surfaces in a list box, you could do that. As you see here, I've got it in a stack panel with a button below it in the XAML Z order. The other element is the one we think is the most useful. It's the one that that you can build games with as well. So it's called Drawing Surface Background Grid, and it's really just a fancy grid. It uses grid layout, and it's really just a fancy grid where you write to the background of this thing directly from C++ Direct3D. So you completely own the background. There's no swap chain. You're writing directly to the device. And then we will automatically composite any of the XAML elements that you have in your application on top of it. So definitely the best performance. And there's a special rule, though, is that it has to be the root level element of a page since you control the background. Okay, let's do a quick demo of what that looks like. Okay, so still under the C++ node, see you here you see the Direct3D with XAML app. It's a mouthful. You'll also find this under the C# node. And what this gives you is actually a solution with 2 projects. I'll show you this in just a second. So since this is a XAML app, it's going to load the designer. Okay, so what this gives you is these 2 projects. So the first is a C# project, which is your XAML application, hosts the XAML and any other assets that you want. The other is all the D3D code. So the way this works, let me just show you some of the code real quick before I hit F5. The way this works is that if you look in mainpage.xaml.cs, in loaded, what's happening is that this drawing surface background grid, which is the name of my drawing surface, that there's a call called set background content provider. What that is it's a little component that you implement that implements a D3D callback interface, and we call you back and you render. Super simple. The other one, the next method you see, the set background manipulation handler, this is how you get input. So since you have a scene where you've got mixed XAML and D3D, you need some way of getting input routed to you, and this is the way. So if I hit F5 on this guy, what do you know? It's the same spinning cube that you saw in the other sample. This time it's compositing with XAML. So let me just prove that to you. So I'll come over to the designer. Okay, here's my drawing surface. Let's just put some text on top of it. So I'll add a text block. Set the text to hello world. And orient it. and set the foreground color. And then give it a size. Make it something big. Okay, close my element. Boom, you see it there in the designer. By the way, in the designer, you just get this little cube icon that says this your drawing surface here. So now when I deploy this guy, you see you've got the D3D content. It's happening at frame rate, being rendered to from DirectX and C++, and the XAML content is automatically being rendered on top. Now, why this is useful is there are times when you have a game where you want text around it, or Chrome, or controls. You can also have a page of DirectX and a page of XAML, for example, for your sign-in or for high score and leaderboards, that kind of thing. So let me stop this guy. So how do you choose between the two? So I just showed you two different ways to write a game. The first is a pure C++. The second is XAML with C++ as well. So our XAML application, the reason why you would use that is if you need access to some of the features not yet in Direct3D app, such as live tile, notifications, and background agents, as well as if you need your own UI. Now, Havok, for example, when they build a game in the Havok Vision engine, they're actually building a D3D app because they already have all those things, and they didn't need them. And so we built this in such a way that if you wanted to take advantage of XAML and all the things that it provides, you can use that model. If you don't need it and you just want us to get out of the way and not have any overhead of anything in your process, you can just use Direct3D app. So it's very straightforward to switch. You didn't see it, but as you play with Visual Studio, the same cube renderer that was just rendering that cube, it's the exact same code that's running in two places. There's just another interface that it goes through. So super straightforward. All right, let's talk about some of the new APIs. So it wouldn't be much of a game if you couldn't get input or if you didn't have access to sensors. So no surprise, you have all of that. I'm going to show you a very quick demo that shows you how to wire up input. And it also illustrates the application model. So let's switch back over. I'm going to go back to my D3D app. Okay, so there's two special methods on iFramework View that you get called back. The first is initialize, and that's when you're first initializing, obviously. The second is you get passed back a window, and the window, let me just show you in the implementation of this file. Okay, so here's the initialize call. This is where you can listen to when you're activating and suspending and resuming. Here's the set window call on iFramework View, where you get passed back the window, and here you can tell, did I just get obscured? Am I closing? And then you can get input. You can also get keyboard input. We give you raw keyboard input as well as pointer. So you'll notice on Windows Phone, we still had in the existing XAML model, we weren't using pointer move, pointer press. This is Windows 8 aligned, so it uses the new pointer events. So here I've got pointer released, and what I'm going to do, go down into pointer released, and in here we've got our little cube renderer, and I'm just going to tell it to toggle. I'm going to write a little code for it, and then I'm going to jump over into this cube renderer, and I'll add a member variable to track that. And all I'm going to do is click on it and change the background and show you what that looks like. Okay, so I'll add a little member variable. I am going to add a method for toggling. And I'll switch over and define that. And all I'm going to do is toggle my toggle. Okay, and then inside this cube renderer, it's got a render method. And what I'm going to do, where the render target's being cleared and rendered to, I am going to change, whoops. I'm going to change this from a constant. And I'm just going to say, if my toggle's set, then I am going to change the R value of this float. Now when I run this in the emulator, you can see that my render is now doing, now normally in a game I would do this during update if it was somewhat complex. Here I'm doing in render. You get the point. I'm changing the background in response to input. You can also pump in, as you get your, you can also feed input into gesture recognizers to handle pinch and zoom and things like that. So let's move on. Graphics. So as I mentioned, we have DirectX 11 APIs. We're at feature level 9.3. I'll explain to you in one slide exactly what that means. So we have a subset on phone of what you would find in Windows. Right now we have no Windows imaging component APIs, which allows you to decode images, or Direct2D or DWrite for 2D graphics or text. For those, we have a toolkit that we've just updated, DirectX Text. It's available upon Codeplex. It's built for the phone now. You can go and grab it and use it for those features. We also don't have GDI on the phone or D3DX or fixed function. And so for that, we have another toolkit, again, up on Codeplex. You can go and use that, the DirectX toolkit. And then we don't support runtime shader compilation. They have to be precompiled, and for that, Visual Studio does it for you. So this is what I mean when I say feature level 9.3. It's shader model. It's not shader model 2. It's actually more than that. It uses the shader model 4 syntax. It has longer instruction set, dynamic flow control. And you see there's some things that aren't included, like geometry shaders and hull and domain shaders. So let's take a look at what you can do with just a subset of this. And so what we've done is we have ported. We ported a popular shader demo. Just a second. There it is. All right, I have something to do. Okay, so we've ported a popular shader demo that you might be familiar with that shows what you can do with these phones. Now this runs, we've tried it on some of the low-end phones, some of the high-end phones. It looks beautiful on it. There's a lot of shaders involved in this, and this is what you can do with the subset that we have on Windows Phone. See the effects that are little blurring effects and diffuse effects. Yeah, you can clap if you want. All right, onward we go. Okay, for audio. So 3 main types of audio that we support. The first is for sound effects. For looping, 3D positioning, and things like that. You can do many of these sounds at once. For those of you that are familiar with this, with Xaudio 2 APIs, these are the same APIs that console games use on Xbox. And so they are industrial strength. We support PCM or ADPCM data sent to those. For background music, we have a Windows 8 aligned IMF Media Engine. Xaudio 2 is also on Windows 8 now, by the way. IMF Media Engine. So for this, you're playing one background music at a time. You can use compressed MP3 or WMA, and it just asynchronously streams either from the file system or from a URI. And we also support raw PCM streams if you just want to capture or render low-level PCM data. So let's take a look. So audio in the game world, let's say I have a few obstructions, and over here I've got some weapon fire and some teammates running around. And over here I've got some enemies and an explosion, and then I've got an alarm. So what this would look like in Xaudio 2 is I have a bunch of memory buffers that represent my PCM data or my ADPCM data. These are referred to as source voices. And to each of these source voices, they can get remixed into a mastering voice before they're sent out to Wasapi. I can also submix some of the voices, and I can even apply effects to the voices after they're mixed. So why is this useful? So I can apply an effect to simulate a player's weapon, off in a corner and shooting across the screen. The nearby alarm here, I'm not applying an effect. I'm just playing an alarm. For the enemies behind the box, I might want to have an obstruction submix. And then finally, then I can do a final effect and a final mix to the output stream. So very advanced audio. For background music, we have IMF Media Engine. I'm going to show you this in just a second. So this is COM-based. It's very simple. You initialize and set a source. You can control playback just like you'd expect. Okay, so let's do a quick demo of that. I'm going to go back to my laptop. Okay. So, write a little C++ for you. So the first thing I'm going to include is WRL, the Windows Runtime Library, which includes a lot of helpers like COM pointers and things like that. I'm going to go into my cube render and add and include. I'm going to cheat a little bit with some macros, but I'm going to show you, I'm going to step through the code. Okay, I'm including MF Media Engine. I'm going to go ahead and add a variable for the media engine. Okay. So you just have a COM pointer into IMF Media Engine. I'm going to go over to my cube renderer. And include MF API. And then one of the things that IMF Media Engine needs is a callback, a phone number to call you back on if something goes wrong. I'm just going to have a little implementation of that where I do nothing. So this is just a little runtime class IMF Media that implements IMF Media Engine Notify. And then the last thing that I'm going to do, actually in my toggle, I'm going to, if I'm toggled, not what I wanted. Oops. Then I'll just play. And if not, I'm going to pause. Okay, and then the last thing that I'm going to show you is inside as I'm preparing my device, I'm just going to add a little code to prepare MF Media Engine. There we go, and I'll hit a breakpoint here. So this is just going to co-create MF Media Engine. I'll step through this code in just a second. The last thing that I need to do is grab a sound to play. So hop back into VS and add an asset. Okay. And I'm going to set, you set content to true, and that means it'll get copied into your Zap, and it'll be available on the device for you. Okay, I should have everything I need. Turn my mute off. Okay, so now when I step through this, and by the way, if you haven't seen, you can debug native code now as well, as you would expect. Oh, I got a linker error. Good old C++. All right. So let's go into the linker and add mfplat. That's how you know it's real C++. Okay, so here we go. Here as you can see, I'm just calling co-create instance. I'm creating some attributes. The attributes hold that notify callback class, which I'm setting on IMF Media Engine. I'm creating an instance of the Media Engine. And here what I'm doing is I'm using our file system support to point to the location of that media in my project. This installed location.path is what you're after. For those of you in the audience that used to know managed C++, this is not managed C++. The little funny hat here is a fancy way of telling the C++11 compiler that that's a COM pointer. So that's all it is. Or a smart pointer, sorry. So then I'm going to set the source, tell it to keep looping, And on we go. Now I get some lame music. Now, the worst part of all this is I really wanted to rickroll everybody, but the lawyers said that we didn't have rights to it, so stupid lawyers. Anyway, so you have to listen to this called Inspiration. Anyway, sorry about that. I'll turn it off. All right. For video cutscene support, this again uses IMF Media Engine. Again, this is pretty simple. You initialize and set a source. You can control playback just like you'd expect. The cool thing, though, is that this doesn't have its own surface. And so you basically get a notification when frames are ready. You can copy those frames into a buffer and then just composite them anywhere in your scene. So if you have a driving game and you want to put a video up on a billboard tilted at an angle, you can do that. If you just want to play video straight on, you can do that. So very flexible. We support both RGB and NV12 formats as well. And then for networking, so Tim Laverty, who's sitting in the back quietly, he has a great networking talk that goes for about an hour, and it covers extensively all of the things you can do with our new networking APIs. If you're interested, I encourage you to go to that. We have all of the things that you see here, except for the last one, are present in Windows 8 store apps. So we support TCP sockets, including SSL, including the ability to listen on sockets. We support UDP sockets using the Datagram socket class. We have peer-to-peer with a new fancy, if you haven't seen it, it's actually really cool. In Windows 8, the Peer Finder class, this supports both Bluetooth and NFC, and it allows you to establish a peer connection, and then you just get a socket back and party on. So this supports not only app to app, like you'll see in Windows 8, but one of the things that was very important for Windows Phone was to support app to device. And so, for example, this morning when you saw the quadcopter, that was talking to a Wi-Fi access point. We also have a demo where we're controlling one of the little Sphero robot balls. That happens over Bluetooth. But in all of those cases, you can connect directly to a device as well as to another application. We also support low-level C++ HTTP, so you can use XML HTTP web request too. And then last, you see a little WinSock hanging out there at the bottom. For those of you that are familiar, this is a very old networking API, full socket API. We added this in response to feedback because what we heard was that there were a lot of open source networking libraries that were using WinSock, and it was going to be a pain in the butt for people to port to the new WinRT sockets. And so we added it to make it easier. Yeah, we're all about making it easier. For the file system, it's all the stuff you'd expect. You can figure out where your app is, where your data folder is. There's files and folders. We support the ms-appex and ms-app-data URIs, so you can open files and manipulate files using URIs. And then we support a whole mess of Win32 style APIs. Again, we wanted to leave these in here because it makes porting from other platforms easier. We're using open source libraries that were already using that. For launchers and choosers, for those of you familiar with phone, the full set of launchers and choosers isn't available to D3D app. The ones that we felt were and that we heard from you as well, were the most important for games are. So you see all of these that are supported. And then our good friends in Visual Studio did us a big solid with a bunch of great new C++ support. Not only do we have templates that you've seen today for D3D app and D3D app with XAML, we also have support for Windows runtime components. So with these are really cool technology if you haven't played with these yet. It's basically, under the covers, it's just a fancy COM object. But it's something that you can write a component in C++, and it is automatically available to C# and VB code, as well as C++ code directly. And then you've got your vanilla DLLs and static libraries, of course. Also in response to developer feedback that we heard loud and clear from game developer toolchains, we heard, I don't want to be opening VS all the time in order to build, debug, and deploy, so please give me command line tools. So we did. We also have CPU profiling, either C++ or C#, as well as some ETL-based profiling events that you can use. And then for game assets, we share the mesh editor with Windows 8. as the texture editor and the HLSL editor, so that you get syntax checking and keyword highlighting. So we've reached the end of my talk. I'm open for questions and answers. If you have a question, please go up to a microphone, and if you forget, that's okay, and I'll repeat it. While you're listening to questions and answers, you can see the schedule of upcoming Windows Phone events at the rest of the conference. So, any questions? Yep.
Is there any plan to support Direct2D in the future?
So the question was, is there any plan to support Direct2D in the future? Absolutely. Yeah, we want to make it as easy as possible to target both Windows 8 and Windows Phone.
Because like a game written with Direct2D
Yep.
already on Windows.
So go check out the toolkits that we pointed you at. I saw another one. Yeah, go ahead.
You mentioned bringing WinSock to Windows Phone to make it easy for compatibility of libraries. But
Yes.
we're sharing code across Windows 8 and Windows Phone. Isn't that an issue since they haven't exposed that there?
That is so the question is, you guys have WinSock, but Windows 8 doesn't, so doesn't that make it hard to port? So we added it because there were a lot of game developers, in our case, that were coming from iOS and Android, that we had heard, that we'd had requests much earlier on than I think Windows did. So it's a great request to reinforce with the Windows team, but we needed to do it to get games on mobile platforms. Yep, in the back.
You talked about potential Direct2D support. Does that include the virtual service image source?
I didn't quite hear. Do you want to use a mic? Sorry about that.
When you talked about Direct2D support that might be coming, does that include the virtual surface image source, the VSIS, that is available on WinRT?
Yeah, that you would use to plug into their XAML application model?
Yes.
Yes.
Okay.
Yes. You will be seeing a lot of conversions. Yes?
At which time frame?
In the next major version. Anyone else? Going once. All right, we're done. Thank you very much for coming. Appreciate it.